Okay, so the first principle is Pascal's principle, which states a change of pressure at any point in an enclosed fluid will be transmitted equally to all parts of the fluid. So my first example is going to be squeezing this toothpaste. So as you can see, when I'm doing this, I'm creating a change of pressure in this toothpaste. Sorry. So when I open it, this is what it's doing. The toothpaste is going out of it because it is a change of pressure going inside in the liquid. So the second example of the Pascal principle is that I'm going to use this spray glade to make a change of pressure when I spray. So when I do this, it's creating a change of pressure inside the liquid. So it is what Pascal's principle is stating. I'm going to talk about Bernoulli's principle. Bernoulli's principle states that as the speed of moving fluid increases, the pressure with the fluid decreases. So my first example is going to be with these cans. So I'm going to blow air in between them to see what is going to happen. So you can see that the cans stick together and they didn't move apart because the pressure is equal to both sides, so they move together. An example of Bernoulli's principle is going to be with two notebooks and one piece of paper. So I'm going to blow air in the piece of paper. As you see, the paper went down a little bit, and because the pressure on top is stayed the same, and the pressure in the bottom decreases, so it makes the paper go down, as you can see. Now I'm going to talk about Boyle's law. Boyle's law states if a volume increases, the pressure decreases. If volume decreases, the pressure increases. So today I'm going to do this experiment with, I have a water in this, and I cut a half of the 500 milligrams of Coca-Cola bottle, and I put a balloon here. So my experiment consists that I'm going to put this bottle in here to inflate the balloon. So here, as you can see, because of I'm pulling the bottle down, so when I pull it down, the balloon is inflated by air pressure, not water. So when I go up, it's totally disinflated, no air, nothing. But when I go down, and so the balloon is inflated by air pressure, as you can see. So up with nothing, and when I go down, it empties. So in this experiment, you see now that the Coca-Cola bottle is full at normal temperature, and as you can see, it's not inflating the balloon. But this is normal water, so when I put it in, it's little by little it's going to start inflating the balloon, as you can see. This takes a little while because of the water temperature, but it's going to inflate. This in a coffee cup is hot water. So I'm going to slowly add it to the bottle. And there's a temperature change, so if you can see, now the balloon is starting to inflate more as it was with normal temperature water, because the temperature changes, so the particles increase. So as you can see now, the balloon is better inflated. So the gas of the Coca-Cola, as you can see, the bubbles that is creating the hot water. So now I'm going to talk about pressure. Pressure is the amount of force exerted on a given area or surface. So I have a balloon that is not fully full, so I'm going to add pressure to destroy the balloon. As you can see, it's not fully full, so it's hard for me to break it. So I need a lot of pressure to break it. So as you can see, it's hard. So it was hard for me to destroy the balloon because of it wasn't fully full of water. So experiment about pressure is with two cans. I'm going to try to add pressure by squeezing the can, but as you can see, one is full of liquid and the other one is empty. So in the full of liquid, for me, I'm going to try to squeeze it, but because it has liquid, it's hard for me to squeeze it. So you can see the liquid, it's hard for me to squeeze it. But this one that has nothing inside it, I can squeeze it really easy because there's nothing inside it and it's easy to squeeze it. As you see, nothing, so I can squeeze it. The difference between... Now I'm going to talk about Archimedes' principle. Archimedes' principle is the wave of the displaced liquid equals the wave of the floating object. So my first experiment is going to be with this piece. So I'm going to put it here in the water. And as you can see, it doesn't sink. It stays there. So now, my second experiment. My second experiment is going to be with this dice, and I'm going to put it in the water. So as you can see, this one didn't float as this one because this has less wave than this one, so it sinks really easy. This one and this one sinks, this one's not. So because of the wave of it, or that it has. That's all I have for my experiment.